Hi, this is Charles from flexAEM, and welcome to the workshop. Today I'm going to introduce you to an axiom with a simple Hello World type example by building a groundwater model of a pumping well in less than 5 minutes. Let's get started. I will begin setting up the pumping well model by entering some general notes information. Distance units are feet, and I'll enter day for the time unit. I'm going to type a project name in the comments field and then save the model file using the name Hello World. Next, I'm going to use the What to Plot menu to tell the model how to display the results. I'll begin by specifying a model viewing window that is 20,000 feet by 20,000 feet. And I will specify that I want to see contours of calculated hydraulic head in the output display. Under the Contour Settings menu, I want the model to evaluate heads at 40,000 points before contouring, and to contour heads using a 0.5 foot interval. Now to actually begin building the model, I will select Model Input, Domains, and enter the data for the aquifer. We'll call this domain Aquifer. It is a one-layer confined aquifer model. The model thickness extends from a top elevation of 100 feet down to a base elevation of 0. Average starting head in the model is set to 200 feet. And I'm going to specify a hydraulic conductivity of 10 feet per day for the aquifer material within this model domain. To set up the boundary for the model, I will draw the empty model window to open the space where I want to begin digitizing the boundary. I'm going to use an axiom's Snap to Grid feature so that my digitizing will be easier. First, turn on Snap to Grid, and then set the snap spacing interval to 1,000 feet. After selecting the Digitize Circle Polygon tool, I will specify 40 points around the circle. I begin digitizing the circle by clicking once at the center, 0, 0, and then moving the cursor out a distance of 10,000 feet. With the coordinates for the 40 points on the clipboard, I select Model Input, Line Boundaries, Head Specified. And in the coordinates cell for the line boundary, I will paste the digitized coordinates for the circular boundary. Then I will enter the remaining information that describes the boundary. Label is boundary. Domain. I want to select aquifer to indicate that the boundary line will be forming the outer boundary of the aquifer domain we created earlier. Head start and end values will be set to 200 feet so that the head is set at 200 feet as a boundary condition around the entire circular boundary of the model. Now we want to add the pumping well to the model. Under Model Input, Pumping Wells, Discharge Specified, I enter the label is well. For domain, I want to specify that the well is to be located in the aquifer domain. XY coordinates are set to the center of the model at 0, 0. Radius, I want to specify 0.5 feet for a 1 foot diameter well. Discharge, I'm going to set the pumping rate to 20,000 cubic feet per day, or about 100 gallons per minute. I use the minus sign to indicate that we are taking water out of the aquifer. I click on Solve, and you can see that the model solves in less than 1 second. To show the results, I select Make Plot Level 1, and the plot shows how hydraulic head values have been lowered around the pumping well. To celebrate our first introductory Anaxim model, we want to add a Hello World label. I'm going to use the Annotate Text tool and click and drag a line that I want to type the text on. And there you are. So that's how easy it is to create a groundwater flow model using Anaxim. We hope you enjoyed this brief demonstration. To download a free copy of this Hello World example, or for more information on Anaxim and the flexAEM system of tools and tutorials, just click on the link in the closing credits to visit our website. Good luck with your modeling projects.